This is Unit 11, Lesson 5, Arithmetic and Geometric Series Formulas. And before we deal with the formulas, we need to understand what an arithmetic and geometric series is. Now, we've talked about arithmetic and geometric sequences, which is what I've got right here. For this one, we go from 2 to 4, 6, 8, 10, and ... It goes on forever. The difference between a sequence and a series is that in a series, we're going to take all of the terms and we're going to add them together. Now, you might say, well, if you add the terms together for every single series, then you're going to get infinity every time. That's true, but they're not asking us to add together all of the numbers from a series, but a specific group of numbers from a series. So they may give us a series, and it could be arithmetic or geometric. This one is an arithmetic sequence. This one is a geometric sequence. It goes from 5 to 10, 20, 40, 80. So in this one, your D value or your common difference is 2. In this one, your R value or your common ratio is also 2. So we're adding 2 to get to the next term in the arithmetic sequence, and we're multiplying by 2 to get to the next term in the geometric sequence. So how do I make this a series? Well, instead of just listing the terms, I'm going to have pluses in between. And your question might say, add the first 5 terms of the following arithmetic sequence. Well, this is arithmetic. If they ask us to add all of those terms together, let's see, we get 6, 12, 20, we get 30. The first 5 terms of this series is 30. They might say, add the first 5 terms of a geometric series. Well, the first 5 terms of that series, let's see, we get 15, 35, 75, 155. So in a series, really the only difference between a sequence and a series is, instead of just listing the numbers, we're adding a group of the numbers together. That's what makes them a series. They could give us a series at the beginning of one, and they could ask us to find the sum of the first 50 terms. That's where our formulas would come in. So if you have something simple like this, where you just have 5 or 6 terms, you use your calculator, get the answer, and that's no big deal. You don't need a formula. But sometimes they're going to ask you to add a bunch of the terms together, and that's where the formulas come in. So I've written the formulas for your series problems here. If I give you a test or a quiz, these formulas will be given to you. Either I will give you a worksheet with them on it, or I will say you can use your notes. So you are not going to have to memorize any of these. That includes the SOL. They will give you these formulas, so there's no need to memorize them. All you have to understand is what the variables represent so that you know how to plug into the formulas. So for your arithmetic formulas, just as a review, your sequence formula is a sub n equals a sub 1 plus n minus 1 times d. We've used that one a lot so far. You may have a need to use that one while you're dealing with series as well. We'll see that through some of the examples. Your arithmetic series has 2 different formulas. The first one is S sub n equals n over 2 times a sub 1 plus a sub n. And we would have to use order of operations to solve that if you don't use a calculator. If you use a calculator, you just make sure that you plug it in exactly as you see it with the parentheses so that the calculator knows how to handle the problem. And as far as what your abbreviations stand for, your variables stand for, S sub n means the sum of the first n number of terms. N is the number of terms that you're adding together. So if they tell you to add the first 10 terms together, N would be 10. If they ask you to add the first 20 numbers together, N would be 20. A sub 1 is the first term in the series or sequence, and a sub n is the last term that they're talking about. So if they ask you to add the first 10 terms, then a sub n would be a sub 10, or the 10th term in the sequence or series. Here, S sub n, the sum of the first n terms, is equal to n, the number of terms that we're adding together, over 2 times 2 times a sub 1. A sub 1 is the first term. And then n is the number of terms we're adding together. Your d is your common difference. You might recognize here We've got the a sub 1 plus n minus 1 times d with that extra a1 tagged in there. That's nothing more than that's the same formula. We've just added a sub 1 plus a sub n, and the formula for a sub n is here. So if you think about it, if you add a sub 1 to this, won't we get what we have here? So there's really no difference there. They've just subbed the original a sub n formula in to get you a second formula. This one is useful if they give you a sub 1 and an n number and you can find d, but they don't give you a sub n. But honestly, if you don't know what a sub n is, you can always use the term number that you're looking for to find a sub n in the old formula. So either way you do it is fine. It really doesn't matter. For the geometric sequence, here's your sequence formula. Again, you might have use for that as we're doing certain examples. The series formula is S sub n, the sum of the first n number of terms, is equal to a sub 1, which is the first term, times 1 minus r is your common difference, n is the term or the number of terms that we're adding together, and 1 minus r is your common ratio again. So, in the first example, I've got directions that say find the sum of the first 25 terms of the given sequence. And then they give you the sequence 10, 14, 18, ... So we're going to find the first 25 terms. Well, you could find the first 25 terms and then add them all together, but the chances of getting that right when you're trying to do that on a calculator are very slim. It's a lot easier to use a formula. So first thing we need to do here is determine, is this one arithmetic or geometric? So do you add something to get to the next term, or are you multiplying to get to the next term? Well, if I add 4, I get 14. If I add 4 again, I get 18. So it looks to me like this one is arithmetic, and our common difference is 4. We're adding 4 to get to the next term. They want us to find the first 25 terms, so that means my n is going to be 25. So they want us to find the sum of the first n number of terms. So S sub n is equal to n over 2 times a sub 1 plus a sub n. I'm going to show you with this one how to use both of the series formulas for arithmetic so that you understand how they both work. So with this one, if I want to find S sub n, n is 25, so I would do S sub 25 is equal to 25 over 2 times a sub 1 is the first term, that's 10, plus, we don't know what a sub n is. So if we want to find a sub n, what I would do is use my original sequence formula for arithmetic sequences. So I want to find a sub n, I'm going to use a sub 1 plus n minus 1 times d. So a sub 25, I want the 25th term for a sub n, is a sub 1 is 10 plus 25 minus 1 is 24, and our common difference is 4. So my 25th term of this sequence is, well, 4 times 24 is 96, so the 25th term is 106. So now that I've found 106, I plug 106 in for a sub n, and then I can finish my formula. You don't have to do that by hand. You can use Desmos or a calculator, that's fine. So a sub n is 106, so now I can finish my problem. I've got S sub 25, the sum of the first 25 terms, is equal to 25 over 2 times 116, and 116 times 25 over 2 is 1,450. And again, you can use your calculator for that. You do not have to do that by hand. So the sum of the first 25 terms is 1450. Now, I want to look at that one using the other formula just so that you can see that we are going to get the same thing. So here's the other formula. I'm going to plug into that without finding a sub n. I'm going to just plug into this formula. So S sub 25, the sum of the first 25 terms, is equal to n is 25 over 2. We've got 2 times a sub 1 is 10. N minus 1 is 24 times d, which is 4. So I have S sub 25 equals 25 over 2 times 20 plus 96. So I have S sub 25 is equal to 25 over 2 times 116, which you may recall we got that in the last formula. So the answer there is 1450. We get the same answer using either formula. So it really doesn't matter which one you use. You only have to do each of them once. You pick the formula that you like the best, that you think is the easiest, and use that formula. The only reason I did it twice was to show you that both formulas work to get the same answer. In the next example, they say find the sum of the first 9 terms and round the answer to the nearest integer. For this one, we need to determine if it's arithmetic or geometric. If I try for arithmetic, from 125 to 50, I'm subtracting 75. If I subtract 75 from 50, I get negative 25, so it's not arithmetic. Remember, to find your R value, if we know that it's geometric, we would divide an existing term by the previous term. So 50 over 125, or we could use 20 over 50. I think that's an easier choice. 20 over 50 will give me an R value of 2/5. And we can check that to see if it's right. Is 125 times 2/5 going to be 50? Well, 125 divided by 5 is 25, and 25 times 2 is 50. So yes, that is the R value. So we know this one is geometric. We want to add the first 9 terms together, so n is 9. You could use a calculator and go out and find the first 9 terms and then add those 9 terms together. I don't suggest that you do that because it's so easy to put one number in the calculator incorrectly. So I would use the formula for this. The series formula is, and I'm going to copy that down, S sub n equals a sub 1 times 1 minus r to the n all over 1 minus r. So S sub 9, 9 is my n value, that's how many terms I'm adding together, equals a sub 1 is 125. We've got 1 minus r is 2/5, and that r value is to the 9th power. I will put that in parentheses. And then that's over 1 minus 2/5. At this point, I would go into Desmos, put that in Desmos, and then get my answer.
So when I put that in Desmos, 125, and then that's going to be times 1 minus 2/5, and I'm going to put the 2/5 in parentheses, and then that 2/5 is to the 9th power, and then I will end the rest of my parentheses. That's the top. Now, it may not be necessary to have these outside parentheses. I just always tend to put them there just to make sure Desmos understands exactly what I need it to be. And then that's over 1 minus 2/5 on the bottom, like that. And that gives me a 208.27, and the directions were to round it to the nearest integer. So that would be 208.
So my answer here, the sum of the first 9 terms, is 208. In the next one, it says find the sum of the first 32 terms, round to the nearest integer. And they give us 2, 8, 14, ... So first we have to determine if this is arithmetic or geometric. I'm going to try for arithmetic first. 2 plus 6 gives me 8. 8 plus 6 gives me 14. So this one is arithmetic, with my d value being 6. They want us to find the first 32 terms. So n is 32. And then I don't know what a sub n is. In other words, I don't know what a sub 32 is. I could plug into the original arithmetic formula for that, or I could use the summation formula, S sub n equals n over 2 times 2 times a sub 1 plus n minus 1 times d. And again, you do not have to memorize these formulas. The only reason I have them memorized is because I've used them so much. So it's okay if you don't have them memorized. Don't worry about that. Have them in a good place in your notebook and look them up every time if you need to. I would suggest that you copy the formula down just so that you know what you're plugging into and you don't make careless mistakes there. So S sub n, that would be S sub 32. We would have a 32 over 2. N is 32. A sub 1 is 2. N, again, is 32, so n minus 1 is 31. And my d value is 6. I'm then going to take that to Desmos, plug it into Desmos, and solve.
I have 32 over 2, which is the same as 16, times 2 plus 188. And that gives me 3,040.
So my answer here is 3,040. Here I've got 3 problems. Go ahead, pause the video, copy the problems down, see if you can get these 3 on your own. And again, you don't have to memorize the formulas, look the formulas up. And then I'll come back in a few minutes and give you the answers. Okay, here I've got the answers. For this one, I noticed that this one is geometric. I'm multiplying to get by 2/3 to get to the next term each time, or 12 over 18 is 2/3, or 8 over 12 is 2/3. So R is 2/3. My A sub 1 is 18. My N is 10. So S sub 10, the sum of the first 10 terms, is equal to 18 times 1 minus R is 2/3 to the 10th over 1 minus 2/3. I'm going to plug that into Desmos, and I'm going to get S sub 10, or the sum of the first 10 terms, is 53.06. Now, keep in mind, sometimes they may ask you to round your answer to the nearest integer. The nearest integer is the nearest whole number. It could be positive or negative to be an integer, but so if I'm rounding this to the nearest integer, that would be a 53. So just make sure you're reading the directions. It's very possible that they might want you to round that to the nearest whole number or nearest integer. For this one, the sum of the first 18 terms, so n is 18. For this, I notice that it's not geometric, but it's arithmetic. I'm adding 9 to get to the next term. I used the longer formula because I did not know what a sub n is. So S sub 18 is equal to 18 over 2 times 2 times a sub 1 is 5, plus n minus 1, 18 is n, so n minus 1 is 17, times the d value, or 9. And then I'm going to plug that right into Desmos, and I'm going to get the sum of the first 18 terms is 1,467. For this one, the sum of the first 12 terms, I notice right away that that is geometric. I'm multiplying by 1/2 to get to the next term, or dividing by 2, you could think of it that way. So S sub n, or S sub 12, is equal to 1 minus R is 1/2 to the nth power, which is 12, over 1 minus R. And again, Desmos does it all for you. You don't have to do any work, as long as you know how to plug in and how to plug into Desmos then properly, so that Desmos knows how to identify the problem and what to do. You'll get your answer 128, very simple, no problem. It's really just a matter of plugging into a formula here.